Our next section is about solving and graphing inequalities. And this should be reviewed from previous classes, but before I do anything else, I just want to make sure that everybody is aware of our different inequality signs and what they actually represent. So we have this one, which is less than. This one is greater than. We also have less than or equal to. And greater than or equal to. So today we'll be doing all of our graphing on a number line. And when we graph on a number line, the two on the top, the less than and the greater than, are always going to have an open circle. And the two on the bottom, the less than or equal to and the greater than or equal to, are always going to have a closed circle. So let's do some examples of graphing. By the way, for these, if you feel like you know how to do them, feel free to pause, try them on your own, and then fast forward to check your answer. Otherwise, I'll go through it. So for number one, we know we have x is less than or equal to 0. What that means is we're going to go on our number line to where 0 is. Because it's less than or equal to, it's going to be a closed circle. And you're going to look at all numbers less than or equal to 0, and so it's going to be all of the negatives, which means you're going to go to the left. For number two, we have x is greater than -3. This one, it's going to be an open circle. The numbers greater than the -3 are going to be like -2, -1, 0, all the positives, so we're going to draw an arrow that goes to the right. So these next two might be a little bit harder. You have probably done them in Algebra 1, however, that is probably the first year that you've done them, so you've probably seen them only once. And we call these compound inequalities. The reason we call them compound inequalities, I'll write that down, is because there is more than one inequality sign. So for number 3, we have -2 is less than or equal to x is less than 3. For this one, the -2 is going to be less than or equal to x, so that's going to have a closed circle there. The 3 is going to have an open circle, and then you're going to shade in everything in between them, and you can just draw a line from one end to the other. Number 4 is another example of a compound inequality. We call this an OR inequality. The previous one was called an AND inequality. So this OR inequality tells us that x is less than -1 or x is greater than 1. So x would be located in one of those two regions. We're going to shade both parts actually. So with the -1, it's going to be an open circle. When x is less than 1, that means we're going to go to the left of that. With the +1, this is a closed circle, and we're going to go to the right of that, all numbers greater than 1, like 2, 3, 4. So that's what our compound inequalities look like. So for the next ones, we're actually going to be solving. And you actually solve these the same way that you would solve an equation, with one small difference. And the one small difference is something you're going to see in number 6. You might remember it from previous classes. So for number 5, we start by dividing both sides by 5. Our final answer is x is greater than or equal to 2. Sometimes they ask you to graph these, but in this case, I'm just going to ask you to solve. So that's our answer. For number 6, we have x divided by -2 is less than 10. In order to undo dividing by -2, we must multiply both sides by -2. Now we have a rule when we're working with inequalities, and that rule is that we continue, when we're solving a problem like this, we keep everything the same as if we had an equation. The only difference is that when you multiply or divide both sides by a negative, you are going to reverse your inequality sign. I'll write that down. You might remember this from other classes. So I ran out of room. I apologize if that's really hard to read. So I wrote, when you multiply or divide by a negative, reverse the inequality sign. So those last two words should be inequality sign. So this problem's a little bit harder. My recommendation in order to solve this is that you get all the variables on one side, get all the numbers on the other. But in these ones, it's especially nice to get all the variables on the side where you'll get a positive value. What I mean is subtract the smaller value from the bigger one. So I'm going to subtract 4x from both sides because rather than 6x, because I know that'll give me a positive 2x. From there, I will subtract 5 from both sides. That gives me negative 2 is less than or equal to 2x. My final thing I need to do is divide everything by 2. I get negative 1 is less than or equal to x. Now, when we're working in math, it's always good convention to have the variable before whatever your number is with inequalities. However, remember when you do that, right now the open part of your inequality sign is facing the x. Actually, when you shift things around, you have to continue to make sure that the open part faces the x. So you get x is greater than or equal to negative 1. So for number 8, we're going to solve a compound inequality. This one's actually kind of fun to solve. You need to get this x in the middle by itself. That's what needs to remain in the middle. So you have to start by getting rid of the 5. However, you're not just going to subtract the 5 from the 8 or from the 10, you have to do it from both. So when you do that, you get negative 15 is less than 3x, these 5's cancel out, is less than or equal to positive 3. We have to go one step further, which is that we have 3 times x. We divide by 3 so that our x is by itself. Once again, you have to divide the 3 by 3. You have to divide the negative 15 by 3. Your final answer is negative 5 is less than x is less than or equal to 1. So our last problem of the day is another compound inequality. This time it's an or inequality, which you can tell because we have the word or in the middle of it. So I'm going to solve this by, I'm going to do each of the two inequalities separately. I'm first going to start with the 2x minus 1 is less than or equal to negative 7. I start with that one by adding 1 to both sides. That gives me 2x is less than or equal to negative 6. Then I divide both sides by 2. I end up with x is less than or equal to negative 3. However, please don't stop there. Believe it or not, that's actually the number one mistake people make on these problems is they stop after doing 1. So you have to go all the way through to the end. I'm going to do the same thing with this equation, this inequality. I get 4x is greater than or equal to 4. Divide both sides by 4. Which gives me x is greater than or equal to 1. The last thing I need to do is I need to make sure I bring down that or. And this is my final answer.